Okay, welcome everybody. My name is Dino Esposito. I work for JetBrains, and in the next few minutes, I will try to give you a quick and hopefully relevant, significant, insightful, why not, summary of what it means to write applications, apps, for Android. The busy architect payoff you see on the slide is because everybody here is, guess what, busy. So it's reasonable to expect that nobody has the time it takes to slowly start on a huge topic like programming for Android. But I often use in my books, courses, presentations, the expression for the busy architect because especially when it comes to mobile, I think that the real issue, the real pain for architects, even developers, and I would say even more for leaders, for managers, is just making sense of what mobile represents, what we can do, in which way we should approach this entire new world. Now, the fundamental point, as I say things, is that mobile is not something you can or cannot choose. It's a must. So like it was internet some 15 years ago, mobile is going to be a kind of breakthrough, making possible things that were impossible or at least highly impractical before. So no way to, bypass the mobile thing, whatever that means. And the mobile thing means something specific, something different, just to every company, every business. Because what mobile actually means is something that is strictly related to the business you run. So in other words, the power of internet, what was that? It was the power of enabling new business scenarios for companies. If you think, if you can, if you're still able, I'm having some troubles and I have probably, I'm not as young as many of you are. But I can hardly think of what the world was before 99. Why 99? Because it was the year that Google went beta. There was a world without Google. There was a world, there was a way to buy books without Amazon. Internet made that possible. Just it brought something completely different, completely unexpected, innovative in our lives, right? Mobile is the same. It's probably much less enticing, much less engaging, attractive because we already have internet, because mobile runs on top of the internet network, sure. But in terms of business, mobile is as much innovative as it was 15 years ago, just the internet. So no way for companies to avoid the trouble of figuring out what mobile can do for companies. And when it comes to this, a sort of mistake that I perceive stronger every day is that managers, management in general, people who are responsible, in charge, people who are paid for contributing to the vision of the company, when it comes to mobile, they are blind. They are paid to be visionaries, but they are blind. Look at Microsoft. It's my favorite company. They have no idea at all of what mobile is, what people want to do, what people need to do. I mean, we don't know, probably, what to do with mobile, okay? And it even makes sense. But someone, the visionaries, the gurus, should tell us, should help us figuring out what to do. I mean, let me quote briefly, 3 seconds, a personal anecdote. I'm a father, okay? I have a 15-year-old son, and last weekend he told me something that makes me proud to be a father. I've been a good father. Maybe for one day in my life, I've been a good father. He told me that what I like in you, really? And my wallet, because he probably wants something back for that. So what I like in you is that you never tell me, you never give me orders. You do this, you do that, or you should be doing this, you should be doing that. You just give me guidelines and leave me free to implement those guidelines, to turn those guidelines into concrete rules that I apply every day. Back to mobile, there are guidelines, general guidelines, but it's up to every company and every people in a company to apply those into concrete action. But everybody is busy because we live in a crazy time, and there's not even time to complain about that. So it's fundamental that there are, as I say things again, contributions through conferences, through classes, webinars, whatever, that just try to summarize the essence of things. So an executive summary of what it means Android development is what I plan to do now. But I want to start from the very, very, very beginning of it. By the 7th day of creation, you know, the Genesis, this is a sort of the genesis of the mobile world. So by the 7th day, God had finished the work, and he had iOS and Android, the only 2 operating systems in this world, in the Garden of Eden. God was resting from all the work he had been doing for 7 days, and the 2 guys, iOS and Android, were playing with devices in the Garden of Eden. And they were naked because no covers were available at the time. Now, you know the rest of the story. You should be able to imagine what could be, at this point, the rest of the story. You know about the serpent, you know about deception, you know about the fruit. Apple was hidden, and God went crazy. So to punish iOS and Android, God said something like, I will make your pains in development very severe, and with painful labor you will give birth to apps. That's why building apps is so complicated, because of the original sin of hitting the apple. But, however, and unfortunately for all of us interested in Android development, God was even stricter to Android developers. And again, you know the rest of the story, right? What it means to write Android applications. Not just you have to use Java to write Android applications, but you also have Eclipse to use as the IDE. So God offered to punish Android, give birth to apps painfully using Java and Eclipse. But to heal the world, recently, and also to have a break, Google brought the new KitKat name for the latest version of Android. And to heal the Android world, also there are a couple of new products, an IDE, IntelliJ Community Edition, or more advanced versions, and more importantly, Android Studio. So this is to say that regardless of what was the original sin, regardless of what has been up until a few months ago, that situation, the tool set for writing Android apps. Today, and for the months to come, the situation is going to be easier, at least because more advanced and more powerful tools are available and will be available in the future to do Android development. Nice. When it comes to Android, you often face from commands, from simplistic commands, you may get the idea that writing for Android is overly complex, is a nightmare. It's really painful, like, you know, God was supposed to make it following the original scene. It's, well, that doing Android development is hard is not completely, you know, a point that makes no sense. It makes some sense, right? But let's try to go to the root of it. The point is fragmentation. What is fragmentation? Looks like this. I mean, this is one of the pictures you can get if you Google for images and having the Android keyword on search. Essentially, what this picture is trying to show is that when it comes to Android devices, there are some very big vendors, some very big players, and then there are smaller and smaller and smaller vendors, every one coming up with something based on the Android open operating system. So it's the area, the gray area here, that to some extent is what is giving you potentially a lot of trouble. So writing Android apps for Samsung, HTC, Motorola maybe, Motorola is Google, devices, that's not a big deal. It's something you can handle. But when it comes to really building an app or whatever kind of solution that involves Android, and you expect to cover the entire spectrum of devices, well, that could really be painful. But on the other hand, that's it. That's the way in which it is. That's the way Android is. No question, it's hard. Period. But first point, you don't have to cover just every single possible device. It's not for humans. Okay? So in the end, and this comes straight from my 2 years of Android development experience, in the end, it's much more sustainable and doable than one may think at first. So I really got crazy when I read comments like, oh, you're doing Android? Oh, good luck. You're doing Windows Phone? Good luck either. I'm not sure you're going to sell your apps. You're going to get paid. You're going to get, you know, you're going to get some business out of your Windows Phone apps. Android has a strong business future. And this is probably one of the reasons why you are here today. And what I want to do is just telling you that using the proper set of tools, choosing them carefully, and knowing exactly what are the hurdles on the way to building apps for Android, you can probably find a way, find your own way out of guidelines to build, to create an environment where you can successfully create apps. So language, IDE, and other options. Let's start from here. So what do you do? Where do you start from when it comes to creating Android apps? First point, the language. Now, if you look at Google, if you look at the official SDK, the language is Java. You are expected to use Java or to learn Java. Now, I don't know in detail what kind of skills you have, but probably you have either Java skills or C# skills. In both cases, you're fine. But even if you are not having this kind of skills, first question, what kind of other language You may use maybe PHP, maybe Ruby. In any case, learning Java is no big deal for any serious developer. Learning Java is no big deal. But there is more. Kotlin. Kotlin is a new language from JetBrains. It's still in development, so expect to have it released, I think, by the end of the year or something like that. Kotlin is simply a new language with a new syntax that basically brings in Java many features gathered from other more popular languages. More popular in the sense languages with features that people like most. If you know C#, you know that in C# defining an event handler couldn't be easier. Object.event plus equal, and then even the delegate or just the name of a function. In Java, this is not possible. It takes a lot more code. But in Kotlin, you can define event handlers in much the same way you do that in C#. But that's just one example. Extension methods are at the foundation of Kotlin, but not in Java, and so forth. So Kotlin, however, is not a set of extensions to Java. It's a completely brand new language with a completely different syntax that has a lot of taken also from F#. So it's a kind of functional language. It has its own syntax, okay? But when it compiles, it produces directly straight Java bytecode for the JVM. So Kotlin can be seen just as a yet another option, yet another language to build Android applications if you don't like Java. What about the IDE and how languages map to IDE? I would like to think that the Eclipse option is a thing of the past now, at least for Android development. I personally have never been a fan of Eclipse. The first day I decided more than 2 years ago let me see what it takes to write an Android hello world fucking application. So I Googled for Android blah 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 and Eclipse. Okay, let's install Eclipse. I installed Eclipse. I said, I'm not going to use this. So uninstall Eclipse. Re-Google, other options for writing Android applications. And then don't ask me why. I mean, if you ask me to list reasonable options for not choosing Eclipse, I don't know. It was 8 at first sight. So I checked out, and I was not even working for JetBrains at the time, and I found out IntelliJ IDEA, and in particular the Community Edition, which is free, exactly like it's free Eclipse. So you don't have to pay. There is no need for you to get licenses, and I didn't want to spend any buck on Android. So I picked up IntelliJ Community Edition and started using that. Now, for a Visual Studio addicted, even the great IntelliJ IDE is poor thing. And I now work for JetBrains, so Visual Studio remains the most beautiful, pleasant to work environment. IntelliJ IDEA is not that bad. And between the Community Edition and the paid editions like Ultimate, the only difference is the license. I mean, Ultimate has a lot more kind of things, but when it comes to Android development, they are absolutely equivalent. So I feel to recommend you consider paying for using IntelliJ only if you are a full-time Java developer. So if you plan to use server-side features, database features, but as far as pure Android development is concerned, IntelliJ Community Edition, free edition, is more than enough. And to reinforce this concept is the fact that Google in this May, announced Android Studio which is an IDE you can download. There's a new build every week, sort of that. And again, I don't know exactly when Google expects to release version 1, but I expect that to be a matter of weeks now. What is Android Studio? It's a fork of the IntelliJ IDEA Community Edition, which is, by the way, I didn't mention that, an open source project. So what Google did was just taking the source code of IntelliJ Community Edition and build on top of that Android Studio. If you install side by side the two products, you see that they are essentially the same thing with some extra UI features or some differences in the UI in Android Studio. In particular, a feature that at the moment you find in Android Studio but not in IntelliJ is a wizard to let you create the icon for the application and attach that one to the manifest file. You have to do that manually, so create the icon using Photoshop, paint this, paint that, just graphical tools, and then you have to attach the icon, the reference to the icon manually in the manifest file using an XML editor in IntelliJ. With Google, you have some, with Android Studio, you have a wizard, graphical wizard, click, 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 to do that. But it's a minor kind of thing, and beyond that, the two products are essentially the same. But Android Studio, free, is going to be the official Google recommended tool for doing Android development. So it's up to you. And Google is, by releasing Android Studio, is essentially stabbing in the back Eclipse. Okay, so Java or similar languages, and the only option that I can think of is Kotlin, Android Studio or IntelliJ. What else? Are there other options as far as Android development is concerned? Yes, there are. And I can count at least 3 options. One is Xamarin Studio, Titanium, and PhoneGap and hybrid frameworks. Now, Xamarin Studio, it's a product and it requires a license fee that, as far as I know, should be in the order of $1,000, I think, per year. I don't know if it's a perpetual license or it's just a subscription. So it does cost quite a bit of money. But Xamarin Studio comes also as an extension to Visual Studio. So you can code for Android right from Visual Studio using ReSharper, using any other tool and extension you usually use in Visual Studio. Another great benefit of Xamarin Studio is that it allows you to use C# all the way through. You always use C#. You don't even have to spend a minute of your time, of your valuable time, because you're busy, learning Java or backporting your C# skills to Java. More, because Xamarin Studio is based on one language, C#, but it also allows you to create apps for iOS, you have the great chance of really writing your code once and use it across 3, maybe 4 different mobile platforms. 4? Yes. iOS, Android, Windows Phone, and Windows 8. They insist to call this mobile platforms anyway. Now, let me point out an aspect of mobile, general aspect of mobile development. The first time I heard a sentence like, write it once and port it to blah, 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 I had all of my hair. My hair were dark. I was much younger. I wouldn't say much thinner because I'm still thin today. I had no kids. I barely had a wife. It was way, way back. A lot of girlfriends also, you know. It was a different world. I never believed I never bought the statement, write it once and port it forever. The first time I remember to have heard this was when Java was introduced in the early 90s. And to balance this statement, I bring the story of a close friend of mine who was in the 90s really one of the few guys all over the world who really worked on a project to port an existing Java app from a Unix platform to another Unix platform. At the end of the project, the guy quit with development and programming and opened a pizzeria. Now, memories of this always kept me quite, icy, cold, to any, marketing gimmick. Oh, this allows you to reuse. You reuse. I use, not always and not necessarily reuse. Anyway, Xamarin Studio tells you that you can reuse your C# code across 3 or 4 multiple platforms. But the fundamental issue is, what kind of code can I really hope to reuse across platforms? Not certainly presentation code. Forget it. Because the user interface and more, the presentation layer code in iOS is different, significantly different from Android, and Android is significantly different from Windows Phone, and only Windows Phone is partly similar to Win 8. So I would say ignore. Look at what could be the code base you are going to have for your mobile apps. Take out the presentation layer, whatever that means, and what remains that needs to run within the device, that gives you a concrete measure of the code you're really going to reuse across platforms. So that is the amount of code that really pays back the money you spend on Xamarin Studio. Let me give you an example. If you're writing a mobile app that is expected to be, let's say, the front end of an enterprise system, everything, the business runs on some server, some cloud, whatever, not certainly on the phone, on the device. So on the device, you'd likely have a presentation, and that's it. You have some code, maybe some application layer code that orchestrates calls to endpoints out of the remote backend you may have. You have no business logic on the device. Just a little bit of orchestration, okay? Get data, or massage data, to the format suited for the presentation, and that's it. So this is the only thin layer of code you're going to reuse out of the methodology suggested by these tools. At the same time, on the other end, actually, if you are writing a game is a kind of mobile app that is expected to live on device for most of the time, and probably a game uses a back end only to save and persist and for reading basic information about the user, about the scores, about, well, I don't know, rules or maybe images. But most of the logic lives on device. At that point, that would make it the amount of reusable code grow significantly. I've seen a few numbers. Just last week, I was at Dev Connections, a conference in Las Vegas, and I had a couple of guys from Xamarin to present some numbers about the reusability level that their tools allow, and they came up with some 60% of code that is reusable if you use their tools. I immediately questioned that number. If you check my Twitter account, by the way, it's Despos, D-Espos, and you can find back tweets I made last week. You find something like, well, I believe that this 60% sounds quite optimistic. Just like they are, as usual, by the way, they were trying to push out numbers in the best possible case instead of at least the average case. And, well, I was right. I hit, actually, the nail right on top. Yes, 60% is probably a game scenario, but an enterprise scenario takes this number, well, not close to zero, but significantly down. What about accelerators, titanium instead? With titanium, we start moving towards the HTML5 area, because the titanium is essentially a JavaScript framework. It uses JavaScript, but it does not use HTML or similar kind of things. So with Titanium, you create the user interface of your Android app, and you code the logic of your app using a framework, a proprietary framework, which requires JavaScript. So you use JavaScript classes, pseudo classes, to create text boxes, forms, layout elements. You use JavaScript to code the business logic, whatever business logic you need to have. So from just the orchestration code that calls into some backend using AJAX techniques, or code that runs locally within the device. The nice thing about Titanium is that you have one IDE, again, proprietary. You write one code base, and then you just choose from the IDE to build it for iOS or for Android, which is not bad at all. The problem with Titanium is, in first place, JavaScript, and in second place, the quality and the features you find in the IDE. Because if you choose Java or maybe Kotlin, Kotlin comes as a plugin for IntelliJ and a plugin for Android Studio. Okay? So using any of these two languages poses no issue. You are guaranteed to have anyway a great IDE, industry award-winning IDE. With Xamarin Studio, you use Visual Studio. Not bad. Or in the worst, you can use MonoDevelop, which is a shortcut version of Visual Studio. With Titanium, you use a framework, a proprietary IDE, that personally I haven't seen for more than a year, but a year ago was very bad. I got news that it improved significantly. It's completely different. It's probably really usable, but I guess it's anyway far, I would say light years far from the quality and set of features you can find in IntelliJ Android Studio or perhaps Visual Studio. And also, Titanium is problematic, is potentially problematic because of the designer, the UI designer. Because in Android, in mobile in general, you need to have a well-done, fully functional UI designer. In a way, with Titanium, just the logic of Titanium, that you build UI by concatenating and composing UI classes together, you have no clue of what you're doing or what comes out of your code unless you have a graphical designer. A graphical designer is expected to be part of the IDE, but you know how it works. Not certainly the first version is the greatest one, so you probably can expect to see titanium to progress, the IDE part to progress for several months to come. That's it. And there is no HTML, however, used around titanium. PhoneGap. Well, PhoneGap is a former brilliant idea, as I say things. I'm not a big fan of PhoneGap because PhoneGap hit me somewhere in my back end a year ago. I had a project that risked to fail because of PhoneGap, because PhoneGap was just not, when we started moving from prototypes to concrete apps, we figured I was too slow, way too slow for our purposes, our expectations. So we had to invent something else on the fly to essentially build 4 mobile apps for 4 different platforms: iOS, Android, Windows Phone, BlackBerry, without PhoneGap, in the same time frame and within the same budget. But more than the budget, the problem was the time frame, because ours was a time-sensitive app that by contract had to be up and running, available for download on a given fixed date. Anyway, PhoneGap, what's the idea? Quite simply, it's all about having an application that consists of a huge full-screen web browser component. And within this web browser component, actually the term used in mobile is web view, but that's it. You display within this full-screen web browser control a bunch of HTML pages that are made of HTML, CSS, and JavaScript. So what you do is you create a bunch of HTML pages, a client-side, fully disconnected HTML app. You save it as resources of the mobile project. And then you use the PhoneGap native API for Android, for iOS, for Windows Phone to package up a scanty, basic native app that only contains the web view and then sets the URL, the start URL of this web view to a location within the application resources where the root HTML page is taken. So all that happens as the user works with a PhoneGap-based application is that it navigates within a browser embedded in the app. And you see what is the problem? The problem is that your performance is affected in first place by the computing power of the device, and in second place by the rendering capabilities of the browser. So you are subject to compared to a regular website, you are subject to the performance of the CPU and the performance, worse yet, of the browser, and how the browser renders JavaScript. And worse, in order to make this app compete visually with the native apps, in order to make any app appealing enough for users to use them and to enjoy them and to like them, you need to add effects. Effects that are native out of the box if you use Java, but are not native, must be simulated using JavaScript. So the more you add JavaScript to your HTML solution to simulate touch, gestures, pinch, zoom, scroll, the more you make it easier for the browser to work, because you add more and more JavaScript to render. So not necessarily, not always, PhoneGap represents the way to go. And as a way to improve on PhoneGap, hybrid frameworks, which essentially offer a mix of, they offer essentially a native app with no logic, just a skeleton, and then web views sprinkled here and there to grab HTML content, which is a way essentially to simplify development, so pieces of the UI are HTML based, but the layout, the skeleton of the UI is native, so which gives a much better perception of performance to users. Okay, now let me show you what it really, yes?
I have just a question. So which approach or which idea would you then recommend for the development team with the .NET background to build the Android app, for example?
Okay, so the question is, what would be the most recommended approach to take for a theme, for a .NET shop, for a team who has significant skills in .NET when it comes to Android? If you don't mind getting licenses from Xamarin Studio, that would be the most natural way to go for a company that has strong .NET skills. Because in that way, all that you have to learn is just a couple, okay, one for Android, one for iOS, so a couple in this sense, SDKs. So you just have to learn how UI works in Android. But it's just a matter of learning how to use a bunch of new classes. You have to learn the data binding works in a slightly different way, but it's no big deal. Okay? So that would, and you still remain within the realm of Visual Studio, using ReSharper, using your favorite tools that express whatever it is. So you don't change environment, you just learn a bunch of new classes. And for what that matters, you are ready to take some of this code and port it as is to iOS, if you need to go iOS at some point, or Windows Phone, or even Windows 8. And now, let me show you instead the Java way to go. So what I'm going to do is, I'll start with building a minimally interactive application. Key facts. We're going to talk about activities. We're going to talk about how you define a layout. We're going to talk about how you get references to elements, visual elements, and how you handle events. Basically, all of these concepts, with probably the exception of references and also the exception of, okay, activities and layout, however, only the first two of this, are important, even if you choose to go with Xamarin and stay in the realm of C#. Because with C#, events are no big deal. You handle events in exactly the same way you do in C#. It's a matter of language. References, so how you capture references to visual elements, is done by Visual Studio and the partial class mechanism that the C# compiler recognizes, which is missing in Java, for example. So layout and activities are the two key concepts you have to focus on. So this is IntelliJ Community Edition, and you can, okay, when you open it up, you can see, I'm not sure you can see everything in the back. However, on this part of the screen, there is the typical Java project structure with a folder called source and another project called res. Under res, you find all of the resources. Under source, guess what? You will find source code. So these two folders are important, as well as the manifest file, which is an XML file you typically find in the root of the project. Let's have a look at the manifest file, an XML file that has essentially one key block, the activity block. So essentially, in Android, the key concept is called the activity. The activity maps one-to-one with a screen, a displayed screen. So the name activity indicates the user interface of the application that allows the user to do some activity with the code. So you can take screen, displayed screen, activity. Put another way, put down the .NET way, an activity is a code behind class. Like in the web forms or in Windows forms, you have a graphical layout and a code behind, an ASPX and an ASPX.C# file. Same is here. Except that the layout is just an XML file, and in the name there is no direct mapping. I mean, you have an XML file that describes a piece of UI, and when you create and instantiate an activity, you just pick up an XML file and say, look, this is going to be your content. But there is no convention, name-based convention like in .NET. But beyond that, the concept is the same. In the manifest, you indicate essentially the list of activities you are going to use. So 3 activities, 3 entries. So any activity to be used must be listed here. And listing an activity indicates, requires that you specify the name, the class name. And also for one of these activities, the startup one, the one that is used to start the application, you need to add an intent filter with an action of main. So this is going to be the main activity, and a category called the launcher. This is the activity I want to be listed in the panel of installed applications, the icon, okay, that the users click to actually start and bring up the application. Another point to be noted about the manifest is the uses SDK. In Android, you have a new SDK every 6 months, or sort of. There's a new update. Today is, I think the latest is 4.2 point whatever. But actually, regardless of the name, the version, the public version name, 4 point this, 2 point that, Google uses progressive numbers to name SDKs. So in the uses SDK, you must indicate, and this is mandatory, the minimum SDK version this app intends to support, and the target SDK version. Number 8, using in this example, number 8 corresponds to Android 2.2. Today, I would say the smallest version number that still qualifies a device for a smartphone. Min SDK version is the one that really matters, in the sense that if the user attempts to install this application on a device that doesn't have at least version 8 of the operating system, the setup fails. Now, let's have a look at the code. Some code. Here we go. This is my activity, and this is the entry point in the sample application. It is a class that extends a class named activity from the framework. And at the very, very minimum, you need to override a method called onCreate. And here you place the code that sets up the user interface and event handlers and whatever else you need to have in order to transform the activity into something fully functional. So let me go straight through the code here. The first line calls the onCreate method on the parent class. I can skip on request window feature. It's a way to hide the topmost bar from the Android UI. Set content view. This is where I'm attaching some UI layout to this particular activity. And the set content view, which is a method on the base class activity, takes something called a weird expression called r.layout.main. Trying to map this back to .NET Do you remember about resources, resx files, and .NET? It's sort of the same kind of thing. In .NET, when you add, say, a string to a resource file, you can give the resource file a public name, and in code you call public name dot ID of the string. So you use, the resource is a sort of dictionary, but in your code you use a strongly typed syntax to point to that particular string or that particular resource you have saved in a resx file. Sort of the same here, where R is a dynamically generated class created at compile time that is the central repository of resources. So R stands for resources. And then dot layout here indicates the type of resources. So R has a list of methods, properties, each representing the central repository of a particular type of resources. So R.layout indicates take the layout objects from the resources and pick up the layout resource named main. And it's only at this point, when it comes to main, that we have some convention-based approach, because main is just the name of an XML file. We need to have under res layout main XML. And when you double click in IntelliJ, and the same is in Android Studio, you see the user interface we're going to have displayed graphically, and you can modify this layout using drag and drop, as you would do on a web forms in Visual Studio. So I can select this, I can move things around, and so forth. You have the component 3 window that allows you, that displays the hierarchy of visual components. You can select them either by clicking on the surface, the drawing surface, or by selecting the element in the component 3. You can also edit, this design and text. You can also edit the same layout, which is basically an XML file. You can also edit via an XML editor. So the layout file is an XML file, and you can edit manually. It's not that different from XAML. I mean, this is much simpler than XAML. XAML is much more sophisticated and rich, but the idea is the same. Let me just point out a couple of things. Yes, there's a weird syntax you have here. Let's say that in this example, I have a relative layout, which is a container. The relative layout is a sort of smart stack panel, XAML stack panel. Actually, I think that the linear layout is just the one-to-one corresponding element to a .NET stack, XAML stack panel. The relative layout is like a stack panel, except it allows you to put elements with respect to existing elements. So it allows you to do, yes, put this element at the bottom of this other. This is the explanation, the rationale behind relative layout, the name relative layout. Now, every element you have here is strictly required to have a layout width and layout height, so the size of the element. But you are strictly and strongly encouraged not to use numbers to give width or size or height, but to use relative measurements like fill parent or wrap content. Meanings are straightforward. Wrap content give the element the size that is enough to contain, to fully wrap the content or field parent, make it as large or as tall as the parent. If you want to use numbers here, then it's strictly recommended just for the purposes of instructing the operating system on how to scale up or down the UI on smaller or far larger devices. You are strongly encouraged to use numbers, 10, 20, whatever it is, but not pixels. The unit has to be deep, device-independent pixels. It can be DIP or just DP. It's the same. This means that you are telling the operating system that you want to assign as the width or height of a given element 20, say, of device-independent pixels. And the ratio between the logical pixel and the device-specific pixel can be 1 to 2, depending on how large, how deep is the resolution on the particular device. So that's a smart way for you to indicate numbers which are kind of absolute from your perspective, but are relative from the perspective of the operating system and mapped on the device. Another point I want to call your attention on here is the weird syntax you can see for the ID attribute. So now we have here a linear layout element whose ID is plus ID slash name. Why plus ID? In Android, when you assign properties or even strings or color, just resources in general, typically strings, text, magic strings, taken from resources, colors, or maybe sizes. You use a syntax that has a name. It's a sort of selector. So this is an ID, this is a color, this is a size, this is a string, right? So ID, string, or so forth, slash, and then the real ID. But with IDs, sometimes you find this plus. This plus is a directive to the compiler, the Android compiler, is a directive that tells it to create an entry with this name in r.id. So add this string here has an ID to the R object that contains all resources. Why we need to add the plus? So we need to tell, hey, look, add this. Because in Android, there are a few predefined IDs. This is an aspect that is completely different from .NET. In .NET, every ID we use in dialogues, in forms, in web forms, Windows forms, XAML forms, every ID is meant to be unique, at least unique into the class that contains it, right? In Android, the list of IDs is application-wide. So, and in addition, we have some IDs predefined. For example, the ID list is predefined. It's anyway added to the r.id collection. And if you define an ID called list, you get an error, duplicate ID. So the plus indicates, look, this is a new one, please add this. If you're going to give the list name to a particular element, and there are situations in which conventions dominate, and this is exactly what you want to do, you just drop the plus. So ID list is fine, plus ID list is wrong, because you are going to get a duplicate ID. Okay, now that we have the view created, what comes next is, okay, let's start getting a hold of references to visual elements so that we can start making some interaction. Oh, by the way, notice that here in main XML, at some point I have something like this. I have an include tag, and the include tag points to a layout element called body, and body is like a user control in XAML or Reza. I'm bringing in the content of body.xml, and body.xml contains an image view, a text view, a view, and another text view. Text view is a label, image view is image, view is a generic view container. I'm using this just to put an horizontal bar. Image view, layout width, layout height, an ID, gravity. Gravity is the Android term to indicate horizontal or vertical alignment, which is center. And then source, which is something called a file called the droid. It could be either PNG or JPG from the drawable folder, and drawable is a child folder under res. Same story for text view, where you see that padding is set to 10 dp. Text color is a color welcome text, and welcome text is the entry in the resources where a color is defined as RGB elements. You can also indicate colors with using the typical HTML syntax. So using a pointer to resources, or just putting here a plain HTML string color is fine, is the same. Here is how you reference strings, string slash, and then the name of the string, and then there's an entry like this in the resources for strings. Now, what we want to do is, I need to find a way to control programmatically any of these elements. So if I want to change the text, the label on screen, I need to get the ID of the text view. I need to capture programmatically a reference to that. And then once I have that, I can have even handlers, or I can just change properties. So the next point is, how can I get a hold of a programmatic reference to this particular element? And curiously, this has never been a problem in .NET since 2005. Why 2005? Well, because at that point, with that version of C#, .NET 2.0, Microsoft introduced partial classes. Partial classes are a C# compiler feature that assumes that the definition of a class can be split, can be spread over multiple source files. So you can have a class 1, class 2, class 3, C#, that altogether form the definition of class, of the class foo, or whatever is the name. This works as long as the class syntax contains the word partial. So this file contains a partial definition of the class. This other file contains another block, another block, another block, and the compiler puts together the things to create a single class that is the union of members found across multiple files. This feature has been introduced in .NET just with the idea of taking away from developers the problem of defining references to graphical elements. When we create, let's say, a XAML file, and we put there, I don't know, a button with an ID of button 1, common scenario, right? Now, we go to the class, to the code behind class for that XAML view, and we can just call button 1 dot, we can just write button 1 dot, and magically, IntelliSense knows that button 1 is an instance of a button class. It compiles, it works, it's great, but except that button 1 as an instance of type button is declared anywhere. We don't see where it is. And worse yet, we don't see where button 1 is declared and instantiated. But it has to happen. Otherwise, it couldn't work, right? So this is the magic that partial classes and Visual Studio together perform. So what happens under the hood is that Visual Studio creates for each XAML view, for each ASPX view, for each Windows Forms view, it creates a hidden partial class where it defines properties, so one entry per each element with an ID in the layout, and instantiates that. You don't see that, but it happens. In Android, everything has to be explicit and manually done. So this is the purpose of the initialize app internal method I have here. And initialize app does something like find view by ID, which is another method on the root class, or ID message. So get me a view object that corresponds to the message ID, cast that to text view and save to a local member. And I do this for every UI element I want to work with programmatically. This is boring, surely boring, but it's also the only way out. Now, I can tell you that I made a personal point to have people on the Kotlin language in JetBrains to implement partial classes in Kotlin. At the moment, partial classes do not exist in Java, do not exist in Kotlin, but just with the purpose of making, to optimizing Android development, we are considering, unfortunately I do not have the last word on that, but I hope so. I make a personal point. I would make rid of this kind of code, at least in Kotlin. And I see myself using Kotlin in the near future for Android development, because it cuts down a significant amount of complexity. Sure, it's not like using C#, because it's another language. It requires another editor. But anyway, it could be, especially for people with coming from a Java background, it could be an interesting way to shortcut. Probably not for people with a .NET, C# strong skills, as long as you are ready to pay the license fees for getting Xamarin. So it's a trade-off. Another painful, really painful point of Java development is attaching an event handler. So I have here the droid reference to the image view I had in the layout. And what I want to do is attaching to the click on the droid image the touch droid code. In C# I would just do droid.click +1 touch droid. In Java, it's a mess. It's a mess, and it requires me to define a view on click listener, and then it requires me to instantiate the listener, and the listener needs to take an instance of to an anonymous class. This is ridiculous, but that's the way it works. So new view on click listener, and then I just define here on click, which calls touch droid. It's Java, period. I've got just today in the email a newsletter from Dr. Dobbs, and the title is Java a dying language? Yes, it is. Yes, it is. Yes, it is. Okay. Maybe 15 years ago, 20 years ago, it was going to be a great thing. Today, this is just ridiculous, but that's it. Unfortunately, if you happen to use Java, that's it. On the other hand, I'm not going to pay $1,000 of license fee not to use this. Okay. Okay, and then beyond that, touch droid just contains the logic that I expect to implement. So I mean, there's a lot of extra layers of code, of wrappers, but it's boring to set event handlers. But actually, it's something you can work out. It's only a matter of finding out the way to make a boring code as quick as possible to write. Okay, now let me briefly show you in action this app. So, oh, by the way, now the emulator for Android stuff, the emulator. This is the Android emulator, and to be able to test Android apps on the emulator, you need to create something called an AVD, an Android virtual device. And there is a tool like this, the AVD Manager, that you can run directly from Tools, Android AVD Manager. This tool allows you to create multiple virtual devices. Each virtual device runs a version of the Android operating system and sets a few requirements in terms of memory, in terms of screen. So you configure, okay, a sort of a virtual machine that you intend to use to test your app. And every time you debug your application on the emulator, you can pick up the particular AVD that is of interest for you at that time, at that moment, right? So you have different machines programmatically created, created via the tool to test closely and effectively your app. Okay, so now when I run the app, it is now compiling, and then it's going to install launching the application, and in a few moments, starting in 10, this is now the application up and running within the emulator. And now the user interface allows me to click over the droid, and when I click the droid, the touch droid just changes the text here. So I touch it once, 2, 3, 4, and so forth. This is a minimally interactive Android application. Now, let's say that you have this app running on a real device. Oh, by the way, just to test the app on a real device, you only have to change the build configuration settings. You have two options, emulator or real device. You pick the other one and ensure that there's a connection, a USB connection that binds the device to the PC. Couldn't be easier. It's really straightforward. Now, what I want to do is, suppose that you turn and change the orientation of the device. In Android, this kills the application and restarts the application. So if now I simulate rotation on the emulator, and I do that using Control F11, it turns, and a couple of interesting things happen. One is that the layout is different, changed. This is a landscape kind of layout, but more, if I click again, it keeps counting right. This is not something you get out of the box. You have to code your way to get this, to get the change to switch to a different landscape layout, and to keep the state of the application. Because what happened under the hood is that the app was killed and restarted. So the state, the number 4, okay, 4 times I clicked before I rotated, that state went lost and had to be recovered from some other places. This is not really different from the story you may have heard about a Windows Phone, those kind of things. I always call the Windows Phone not the view state. It's called, I can't remember. Anyway, it's nothing special. You have to find a way to preserve for a short amount of time this information. Let me give you an idea of how it works. The easiest is under res. I mentioned you must have actually a layout folder that contains all of the XML files for all of the layouts for the various views, activities, and elements you're going to have. And that is mandatory. If you only have the layout folder, then you only, whatever is the layout means portrait. So you're going to use the same portrait style layout for any scenario, regardless of the actual orientation of the device. If you want to distinguish between portrait and landscape, you create a layout-land folder and just put there with the same name but different content the layouts you want to be different. That's it. You don't have to provide a landscape counterpart to just any layout file you have in portrait. You just place there, you just override only those that needs to be overridden. Because depending on the content of the UI, it could even be that the portrait works well enough, good enough, and in landscape mode. If you don't have that many content, that much content, it could even be that you don't need to change that, or you don't care. Okay? But if you want, just layout land and replace, duplicate files, same name, but different content. And that fixes automatically, by convention, I would say, the rotation issue. When it comes instead to preserving state, well, it's where the parameter on create, this one comes into play. By design, the onCreate method receives a bundle object. Bundle is a dictionary. Okay? Saved instance state, that is the name of the formal parameter. And well, once you have finished the initialization of the activity, what you do is checking whether saved instance state is not null. And if it's not null, you extract from this dictionary any values that you find of interest that you know could have been passed back to you, and use that. So, and where is that you write into this bundle? Through the override for onSave state, onSave instance state. This method is called whenever the app is going to be killed. So you just write into the out state an entry counter, and you save there, in this case, just a number that indicates how many times I clicked on the droid, and this number is retrieved app here when the app is restarted, and then update view is just a call I've made there just to refresh the UI. So that's the way in which it works when it comes to preserving state information across different restarts of the application. And this is a common pattern that you want to employ nearly on every activity. Okay, now let me switch to, let me see if I missed something. Yeah, using additional activities. Okay, fine. So I can just proceed with another demo. There you go. Here is another more sophisticated code. Let me first show you how it works. Because now, in the example that is now trying to compile, you will first see a home screen with a big button, connect. And when I click this button, I jump to another activity. So I change view. Okay, let me click because it can take a while to do something. Yep, it is now displaying a progress bar. It is now connecting to the internet. is getting some RSS feed. It is manipulating the RSS feed, and then it's creating a list view with one entry per each downloaded text item. It is downloading tennis news, I think. Okay, it takes a few moments. Let me switch back from there, and let me bring up again the manifest file for this new project. And in this new project, we find now under the application node, we find two activity blocks. This is the one with intent filter for the root activity, and we have another one that just has the name attribute, and the name attribute points to the class name that just lists a secondary activity I'm going to start at some point. I'm going to launch at some point in the lifetime of the application. But the activity must be listed here. Otherwise, it won't work. And speaking of this, let's also have a look at the top of the manifest file, here precisely, where we have a couple of use permission elements. Now, in Android, permissions are a very, 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 very serious point. I don't know if you have some sort of familiarity with other mobile platforms, but as far as I know, in iOS, there's nothing like permissions. And in Windows Phone, it's nice, Windows Phone, it's very nice. There are permissions, except that the operating system couldn't care less. So the operating system gives you a way to put permissions in the manifest file, except that it doesn't trust you. And when the application is actually packaged for the marketplace, permissions are automatically, programmatically discovered, required permissions are automatically discovered, and they are popped up to the user for acceptance. Android instead says, look, I couldn't care less of what you do, also because the Android apps can be deployed outside marketplaces. So they say, look, it's not about me, it's about you. So you, developer, are responsible for listing in the manifest file the permissions that you require from the user in order to use your app. So you have to think of permissions like questions, like permissions you are requesting from the user to give you, to grant you. And in particular, you are saying that for this app to work, you need to access the internet. And you want permissions from the user for that. You also are requesting the permission of checking the network state. And that is one of the things, the red lines, the red buttons, the red bullet points, that the user that tries to install this app for the marketplace will be asked. So look, you are going to install this app, but are you aware that this app is going to use the internet? Are you aware that this app is going to check the network state, and so forth? Local storage, access the contacts, phone calls, whatever. There's a long list of permissions, and the permit defined in the SDK. And each of these permissions is bound to a segment of the API. So if you happen to use the API without having declared permissions, related permissions in the manifest, the API is going to fail, and you sometimes can hardly figure out why. So I invite you to, if you run into something weird, and typically I regularly do this when it comes to local storage, if it doesn't, in Android, we can say like this, if it doesn't work, before you start blaming gods and Googles and companies, check your permissions, okay? And then, if it doesn't work, then panic, okay? Back to code. This is the root activity now, and when I click the button, connect, the big button, connect, out of the event handling, blah, 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 this is the code that runs, go get feed. And this is the code, these two lines of code shown here are responsible for launching an additional activity. So just to jump, to navigate to another screen. Intent, what's intent? Intent is a concept in Android that indicates essentially a message. Your intent, right? A message for the operating system. And the message in this case is launch this class. So you create the intent, and then you call the method start activity. Let's ignore what follows for a moment. Start activity I intent. And it just pops up the new activity. Now, activity windows are put on a stack, and the only way for you to navigate back from the user, navigate back from the stack is through the back button. If you programmatically call an activity you opened before, another one will be opened and put on top of the stack. So you have a little limited control, programmatic control over the stack of activities. Now, the next question is, okay, I'm going to launch an activity, but sometimes the launch of the secondary activity is a fire and forget kind of operation. Sometimes it is not. Sometimes you want to get back data, and sometimes you want to pass information from the parent, the launcher activity to the launch activity. How can you do that? If you want to receive results back, you, instead of start activity, you call another method, start activity for result. And if you want to kind of synchronize the launcher and the launched activity, you might want to define some sort of unique number that identifies the caller, the launcher, I'm sorry. So let me bring up the activity here. This is the activity that is launched, and this activity, notice, it extends list activity, not simply activity. So it means that this one here is an activity whose user interface is predefined. So you are not necessarily responsible for creating the XML, the layout, but because this is a list activity, it's a list box. It's already a list box. It's just like an activity, predefined activity that displays like a list box or a list view. Okay. So in onCreate, okay, I call set content view here, but that is just, I mean, it's not strictly required. I mean, it's because I want to have also other elements in the, I mean, if I omit this line, because the base class is list activity, I'm still going to have a list box, but I will have a full screen list box with no header, no footer, nothing else. Okay? If I want to have a list box, but with something around, I define set content view, but in set content view, at some point, I put there a list element with the list ID. It has to be list. It cannot have another ID. And then I just use async operations to connect, download data, and out of this, 2 lines populate the list. Okay, let me, before I'm almost done, let me now show what happens when you want to receive back results. So how the communication between elements take place, between activities takes place. So current intent, yeah, here we go. So when this activity is launched, it just uses the put extra and get extra on the intent as a dictionary where data is passed and data is retrieved. So the intent has an attached dictionary of values that the launched activities will read, and it's there, the launched activity and related classes store information to be retrieved as results by the parent. And the parent activity, let's say, feed hunter, here we go. Will override on activity result to retrieve from intent the values that are the results of having launched a child activity. So essentially there is no direct exchange of values, but everything takes place through a dictionary attached to the intent object. And the intent is the message sent to the operating system to trigger a new activity, and it comes with an attached dictionary for data exchange between the two activities. That's in the end, this is the story, this is how it works. And just a couple of more minutes to summarize what it means, data binding here. Data binding, yeah, here we go, passes through the creation of containers and so essentially the container, I'm sorry, the adapter actually. The adapter is the component that obtains a container, a collection of items to bound. So you need to have an adapter. I mean, every UI element that could be populated with data that is subject to data binding needs to have an adapter. The adapter is a concept very similar to the data source concept we have in .NET. It's called adapter in Android. In this case, I have an article adapter because it's an adapter that data binds objects called article. You have basic adapters that just attach strings, plain strings. So if you want something more sophisticated than plain strings, typically objects, you have to create your own class, your own adapter class. And once you have, and you build an adapter class from a plain collection of elements. So articles here is in .NET will be an list of my article data type. And around the plain collection, you build an adapter. And then you set the adapter to the element, the list box, the list view, whatever it is, that will populate its content out of a collection of data. And internally, the adapter article adapter has a fixed structure, and essentially it's based on a getView method. So this method is repeatedly called for each element in the list view, and the getView is responsible for extracting the template, populating the template, and returning a view that represents the template. So mapping this concept to .NET, the adapter is a piece of code that wraps together, that joins together the data source and the template to be repeated, and contains the logic that loops through the collection and applies the template to each item and attaches everything to the final UI. So it's a little bit more sophisticated, well, complicated actually, than in .NET. It's much easier, more straightforward in .NET, but actually we are still talking about data binding. And this is precisely what I meant when I said at the beginning of the talk that when it comes to Android and when it comes to iOS, the biggest effort for you will be just understanding how presentation and, for the most part, data binding actually works. Because, and these are skills you are forced, no matter what, to learn. Otherwise, you won't be able to arrange applications for Android. And this kind of skills are independent from the language. So you have to learn these kind of things, whether you use C#, whether you use Xamarin, whether you use Java or Kotlin. It doesn't matter. You have to learn how it works, data binding, what is the mechanism of layout files, what is their syntax. All these are all kind of things you have to learn regardless, because they are Android specific. And these kind of things are certainly not reusable across mobile platforms. So in iOS, it's going to be different than in Android, which is different from Windows Phone and Windows 8. This is different regardless. Every other kind of code, so mostly logic, that could be reused. But depending on the type of application, the percentage of really reusable code can be very, very small, to the 20, 30% of the overall code base. And it will never be, I think it's a good estimation, more than 50, maybe 60 something % of the code base. So at least you have a 30% of code that is unique for every mobile platform, and it has strictly to do with presentation. No way, that's how it works. And it's also nearly impossible for companies to try to come up with a unified presentation language, pseudo language. Maybe, but maybe theoretically it's even possible, but it's probably not worth the cost, or at least it has been not worth the cost so far. Okay, what else? Not covered here. But essentially, there are a lot of predefined constructs for basic UI, like input elements, dialogue, preferences. I mean, Android has a native feature, native activity, to define settings of an app. There's a lot of features for advanced UI, like menus and reach controls. And then there are receivers, which are background components that are automatically started the first time that something happens, or the first time you run the app, or they are started periodically. So they are periodically stimulated by test checked by the operating system. It depends on how you configure these receivers, but they run in background. They don't have a UI. They do something, typically checking internet or whatever. You can have a receiver that periodically is triggered, checks something on the internet, and then pops up toast messages, notifications, these kind of things, to notify that something has happened somewhere at some point. You can also use receivers to automatically update. You can bound a receiver to a system event like change of state of the network state. So when the internet comes or goes, via a receiver you can detect that and automatically refresh the state of the app, graying out or enabling buttons. Just an example of what you can do with receivers. Challenges of Android development: multi-screen and multi-layout. So for a realistic application, you need to consider at least a couple of screen support, so very small and average, or maybe small, average, and large. I'm talking about smartphones, not to mention tablets. Multi-layout means, but for each screen you can have different layouts for some views, or multi-layout also means portrait and landscape. You need to have a strategy defined for the long tail. So for the area, the small area, if you remember, that I cut off of the fragmented devices, you are be ready to receive a lot of feedback. Oh, it doesn't work on my device. What kind of device? It's a made in China device, blah, blah, blah. Yeah, it's a what's your device? Be ready to that. HTML could be a way out. So you can have, for devices particularly small, and you have a ways in Android, you have to check out the documentation to how to identify the long tail of devices. For them, you can have a completely different layout, which is essentially a web view with some HTML inside. And HTML can be either downloaded from internet, just plain HTML, or it could be inline HTML, static, hard-coded in the application. But having a strategy, and a strategy could be, I don't care. That's a valid strategy. I don't care about the long tail of devices. But being aware of the problem is an aspect of it that I feel heartily to recommend to bring to your attention. Let's talk WebView, and I finish here. This is an extremely powerful approach. I personally, my company built last year 4 apps for a tennis tournament, and we started with the idea of using PhoneGap. We dropped PhoneGap along the way because it was too slow, and we solved the problem by building for each platform a basic app with just navigation between 4 pages, and each page was built around a WebView. WebView downloading content from internet, from a website, a mobile optimized website. It worked beautifully. It was approved by Apple and Microsoft. And more importantly, the first day of the tournament last year, we had the president of the Italian Federation. Okay, an idiot, but you couldn't find any better. He came and he said, I don't like text, I want to see a bitmap here. Now imagine changing a bitmap in a mobile app, even in Android, that it doesn't pass through approval cycles. It would have meant to, okay, fix the app in 3 seconds, but uploading, repackage, upload, wait a couple of hours for the app to be distributed widely, and then have people to download and refresh the app. Instead, with the WebView approach, it took 3 seconds to fix and 3 seconds for the people to have refreshed screens. So WebView is a very, very powerful approach for mobile, not just Android development. Thank you.